Good day, guys. Thank you very much for watching my channel. My name is Renato, CCNA Network Engineer and Junior Python Programmer. And today we will be talking a little bit more about the basics of the CCNA certification, especially about the networking fundamentals. What we will do right now is we will go to the search engine and we'll search cisco.com space OSI. That's the Open Systems Interconnect Reference Model. This is a very important model that describes the communication between networks. And it's very important to understand how it is divided by layers and how those layers describe what happens from a computer end whenever we send some data to another computer inside of the network or outside of the network. All right, there are multiple steps that the data has to go through so it can be successfully sent over. Some data has to be added to the actual packets. We also have some frames. We add some information about the source addresses and the destination addresses. That way, all of the networking equipment forwards the information we want to send to the destination devices. And that's pretty much what we do in the networking field. We prepare the networks accordingly so that the OSI and TCP model reference are taken into account for the communications to happen. As you can see here, we have multiple websites. From on one side, we have the learningnetwork.cisco.com. We have an OSI model reference chart. We'll see it in a moment. And if we scroll down a little bit more, we have cisco.com, fundamentals, and then this other one. I'll open this one, OSI reference, model of reference. That's from the learningnetwork.cisco.com. There's a lot of study resources on the Cisco community and official websites that we can check. They're very well designed for our understanding. That's right now we're looking at the OSI model. All right, and here, as we can see, we will see an overview, quick overview. So whenever we're handling a device, such as the one that the cartoon was, I was going to say gentleman, but yeah, the cartoon there is working with is kind of like a tablet. It could be a smartphone, it could be a computer. So there in the image, it has kind of like a picture. It could be a chart, it could be a website. Depending on whatever application we're using, we're gonna be handling a certain type of file extension and also networking protocols. Here, the first layer on the OSI is the application layer. All right, it provides interface for users to interact with the network. That's the very first layer. It talks about the output that we see on the screen, pretty much. The applications that we're working with, the files that we're actually working with, and the operating systems, such as Windows, Linux, and all of those images that we actually see on the screens, and the ones that we interact with in the form of input from our peripheral devices. That's why it's important to know a little bit of the fundamentals. I remember I took the CompTIA certification a while ago, where they explain all of these details in a deeper manner. They talk a lot about the protocols. They explain very well on the CompTIA certification what protocols actually work with certain applications. For example, browsers work typically with HTTP. We also have DNS, domain name services, which help us translate the names of the websites into IP addresses actually, because in the network they actually use IP addresses to be able to send the packets to the destinations. Now, FTP is file transfer protocol. Certain applications actually use file transfer protocol to transfer files. Usually that's a TCP protocol. We'll see later on. Telnet, that's for communication and management. POP3, and each of them have a port as well that defines them. So that's why I recommend you, if you have questions about the application layer, go through the CompTIA certification as well, because that's a very a good way of learning all of the details for these protocols we're talking about. The devices, as we said, could be PCs, firewalls, IDS. Layer 6, that's the next layer. As you can notice right now, we're going from top to bottom. Layer 7, then layer 6. So we're decreasing the number. 7, 6, 5, 4, 3, 2, and 1. until we reach the last layer. All right, we have 7 layers in total. So the presentation is the second one, we can say, or the next one, better said. And it negotiates and prepares the data. It encrypts it and decrypts it, as well as compresses it. So whenever we have a PDF file, a PowerPoint presentation, an Excel sheet, a Word document, a Docs document, whatever document or file, JPEG, PNG, or videos, or anything we can transmit in the form of file, gets actually encoded, encrypted and decrypted. Whenever it reaches the destination, it gets decrypted. That's for security. The HTTP would go unencrypted. HTTPS would go encrypted in terms of web browsers. So then what we have here is the layer where actually the data that we were looking at on the screen in a human interface form gets translated into an encrypted form for the computer to understand. It can be named ASCII, or whatever secure shell layer, whatever protocol that we're encrypting the information with. So for example, HTTPS uses a secure shell layer, and SSH uses MD5 encryption for passwords. So it depends on the technology that we're using to encrypt, but the presentation layer, that's what it pretty much does. It also helps us separate the data, prepare it for it to be sent over on the cable, because as we know, the cable actually has a limit speed, a limit rate. For example, fast Ethernet, 100 megabits per second, so 100 million bits per second, and 1 gigabit interfaces, 1,000 million bits per second. So the bits are actually sent one by one. All right, so the files are actually chopped so that we can send them over, and then kind of, we could say, digest it. Right now I'm talking about food now. I'm doing an analogy so it can be understood. So it's sent through the esophagus, so we can say the cabling that we have on the network, and then it reaches the stomach, or we can say the destination, right? And then once it reaches that part, it goes back to the application layer. That's where the decryption happens. So there's a translation. That's why here it says it can be viewed as a translation, actually. In the other file, we'll see that. So then layer 5 is the next one, session layer. So what it does is it maintains sessions, multiple sessions, management sessions in a client connection. All right, and it assigns an ID to each session. What does it mean? Well, it means basically that sometimes whenever we send information, well, normally we're working with multiple sessions in a computer that correspond to a specific application. So we're not only sending just one bulk of files and data related to one application and just one file specifically. Sometimes, most of the times, we're sending actually multiple of them. All right. So, for example, just to mention a practical example that's easier to understand. Whenever we're working with the browser, we're actually using multiple tabs. And in a tab, we may have, even though we're using the protocol HTTPS, which corresponds to 443 port, or HTTP, which corresponds to port 80, or we could even use other different protocols. What we're doing there is we're using, yes, just one specific protocol. But how do we identify each session or each of the tabs that are actually open in the browser? That's where the ID number that is mentioned right here is used to identify each of the sessions, because in HTTP we could be using a tab where we're downloading videos from YouTube or uploading videos to YouTube, and in another tab we're reading a document from the encyclopedia, from Wikipedia, for example, and so on and so forth. We could be using multiple batches or multiple bulks of files that correspond to the same protocol, HTTPS in this case, but we identify it by using the ID numbers. Then we go to the fourth layer, transport layer, and this is where we start seeing the data actually starting to talk about the transportation. These three upper layers are called local layers, or also application layers in general, all of them. Whenever we talk about the TCP/IP model, which is parallel reference model that we have similar to the OSI, which is meant for network engineers, to simplify it a little bit, all of these three layers are actually condensed, the layers 7, 6, and 5, into just one layer called application layer, which is the fourth layer. All right, you will see that in later on whenever you investigate for your studies, but it's pretty much the same thing, just that all of these three layers are just condensed into an application layer to simplify it. And what happens is that all of these processes are local to the computer. All of the application presentation, and session, they happen locally in the computer. And then what happens in layer 4 is that now we start creating some things called segments. The segments are pretty much like packets, but not to confuse them with the layer 3 packets, which we'll talk later on. But they're like packets, they're just called segments to differentiate them from the next layer, layer 3. And these segments that we're talking about, they can use the protocol TCP or UDP. And what they do is they actually create a connection-oriented, or in other words, a three-way handshake, in order to ensure that all the packets that are sent are actually delivered to the destination, or a connectionless, so-called UDP protocol, which is just sending the packets without actually acknowledging that they are received on the other side. So if some packets are dropped with the first protocol we mentioned, the TCP protocol, there's a three-way handshake that ensures all the packets are received on the other side. If the other side actually mentions to the first sending device that some of the packets were lost, then the first device will procure to resend those packets that were lost. In the second protocol, UDP, that's missing. That function is missing. It's actually, if some packets are lost, they're just lost. All right, that happens usually with voice and video conferencing. That's when we would experience a dropping of the voice, for example. Maybe the person was talking and some packets were lost, and the connection was lost for a moment, and then you need to ask the other person to please repeat what they said because some packets were lost, for example, just to mention a practical example. And connection oriented is usually used, TCP is usually used with files or file transmission protocols such as the HTTP or FTP, where we want to make sure we get all the packets, because only that way we will get the whole video and the whole picture or the whole file that we're actually sending. This becomes very useful when we're talking about QoS later on, because we can manipulate the data depending on the nature of the TCP or UDP protocols that the files are using. Now we continue with the layer 3. Layer 3 is actually responsible for routing, and this is also already talking about the transportation or sending the data over. And this is where we start talking about the routers, types of devices, because the routers understand IP addresses. They read the source IP address, so the IP address that corresponds to our computer, and then it reads to the destination, and it has a routing table where it compares the destination IP address to find the best destination possible. Then we have multiple different protocols which have different costs. We will talk about that later on, because we could do static routing where we define some routes manually, or we can also use some protocols so that they are assigned automatically, such as OSPF and EIGRP, BGP, and others. So right here, what it's talking about, then the network layer is responsible for sending the data between networks. All right, we can have a local network, and then in the local network, if we have sub-networks, then we will need a router to actually route those devices between those internal networks. And if there's an external network, we will also need the network layer with a router to be able to send that information over. Now, we continue here, and it says protocols IPv4, IPv6, the ones we mentioned, EIGRP and OSPF. So data link layer, sorry. So it sends the traffic from the network segment VLAN. It provides flow control, so it happens in the physical layer. Say layer 2 actually happens locally in the local network that we're communicating from. And here the device in question is the actual switch. So what happens here is the switch understands the MAC addresses. Instead of understanding the IP addresses like the previous layer with the routers, the data link layer actually understands the MAC addresses, the source and destination MAC addresses. Initially, it ignores any of them, so it has a MAC address table that populates dynamically according to the frames that are actually being sent over. Actually, just to mention here, to clarify, on the layer 3 network layer, we have the packets. And here on the data link layer, we have something called frames, all right, which actually contains the MAC addresses, source, and destination. Whenever the host sends a file, it sends a frame with the source address, which is its own MAC address. The switch has a CAM table, content addressable memory, and that's where it stores dynamically those MAC addresses to be able to be sent over. And it's based on the source MAC address. Then it has to find out the destination address. That's where the address resolution protocol comes handy, because that's the one that, based on the layer 3 address, will actually ask the other device on the network what the actual destination MAC address should be. If the device is in the same local network, it will automatically you only switch the frames to the destination based on the destination MAC address being the computer that the information is meant to. But if the actual device, the destination device, is in a different network, then it will send it to the default gateway, which normally is the interface of the router of the first hop, also called the first hop because it's the first router that is immediately available in the network. And then that router will actually forward it to the next hop according to the routing table. There will be a decapsulation and then a re-encapsulation on the devices. So here the data link protocol only works pretty much with the MAC addresses. That image that we see there is an actual icon that represents a layer 2 switch. And then the first layer, layer 1, which is the physical layer, it converts the data to electrical signals to be sent over the wire. All right. What it means is that we're also talking about the data being sent over, but instead of talking about the addresses that are used in the packets and in the frames that are being sent over, in the physical layer, we're already talking about the physical perspective of the devices. So we're talking about the equipment itself, the electrical signals, and how they are transferred over the physical medium, meaning the copper wires and also the fiber optic cabling. We also have some other types of devices that can be considered layer 1 devices, which are the hubs and the repeaters, because what they do is that they actually just replicate and propagate through all the ports that they have the same signal as it's received. They avoid changing anything or actually memorizing anything like the switches do. They memorize the MAC addresses and they forward and switch accordingly. The physical devices actually just forward the frames exactly, or the information actually, just exactly as they receive it. Then here at the bottom we see encapsulation and de-encapsulation. So in a few words, it's actually just the process of adding the headers as we mentioned it. So here, layer 7, actually we start compressing, preparing the information. As we go down, we start adding a header, which is the segment header, and then we add an additional header, which is the network header, which has the IP address and other information of the layer 3. It could be the DSCP field, for example, for QoS, quality of service. And then the data link, we start adding the MAC addresses header, as well as a trailer, which is a frame check sequence. And then finally, the information is sent over in the form of bits. All right, even though we have the MAC addresses in decimal format, it's very important to be able to convert the information from hexadecimal MAC addresses to binary bits, as well as decimal to binary, to be able to understand the flow of data. It becomes handy also later on whenever we start examining the packets with a technology which is called a packet sniffer, such as Wireshark, that helps us monitor all the data as it's traversing the cabling. All right, one point to another. It will become very handy to be able to read. Like, remember that movie from Neo in the Matrix, whenever they see the screens and they just see all the characters on the screens, but they understand what's actually going on, what they mean. Basically, pretty much that's it. That's what happens whenever you understand binary, whenever you read those packets, whenever you start reading the information as it's being monitored and analyzed, you understand what's going on just by reading the bits. So it becomes a little bit of an alien language whenever you're doing it to other people. To the most novice people, they wonder what's going on. How did you know what the destination was and what the priority was? So that's why, because you understand binary. You know what values correspond to all the multiple fields and what those fields signify. If they signify, for example, giving a priority to a certain type of traffic, the destinations of the traffic, you know which ones are corresponding to MAC addresses, which ones are broadcast, which ones are unicast. All of those little details, you're able to actually get to know them by converting from binary to decimal to hexadecimal. So you have to be very sharp. There's actually a game that I want to show you about. Actually, I can show you in a moment. There's a binary game from the Cisco website. Probably you already know it. It's very useful to be able to calculate, convert from decimal to binary. It's a very good practice. All right, so then that's it for this file. Actually, I wanted to show you, we had another file here, which is networking fundamentals. And here we go. 7 layers of the OSI model. It's the same thing pretty much. And it explains each of the layers. All right. Just as a reminder, we went to Google, as easy as that, and we just typed in cisco.com space OSI, and we got all of these very useful files. Most of this information is repeated actually on the official CCNA guide, which I also recommend you to read, but sometimes it's useful to have multiple ways of explaining it. So here we have a very nice explanation about all of the basics, the topologies. They go from all the fundamentals of what is a network, multiple devices interconnected and the combinations of them, what's a local area network, metropolitan area network, which is just multiple devices connected in a campus, wide area network, which is multiple campuses connected in between in larger distances, WAN technologies, what's a lease line, which is a serial based line. It explains to you the previous technologies that were used also, and then the hubs, which repeated all the information all the way through all the different devices. Then we have the switches as well, and these switches actually switch based on the MAC addresses. Then we have the OSI model, which consists of the multiple layers that we saw before. And then we have the application layers. All of the upper layers, as you can see, they right here, they're mentioned, as we said before, as the application layers, all of them together. So network processes to applications, data representation, which is basically the translation that happens. And then it just jumps directly to the transport layer. So flow control actually also happens in the network, in the transport layer, to add more information to it. So what happens is that there's a windowing as well, where the speed of the cabling is actually sensed in a specific time. All right, and it's different than the speed sensing that the interfaces do, which also happens. Now we have the data delivery as well. in the network layer, as we saw before, and we also have QoS happening there. The QoS is actually mentioned briefly in the CCNA certification. For the CCNP certification, we have to go a little bit deeper. We have to actually know marking, classification of the traffic, shaping, policing, defining thresholds, bandwidth, all of that. And here we have data link, which is also based on the MAC addresses and then the physical layer. All right, here actually it explains very nicely what twisted pair cabling is. It has an RJ45 connector, and it has 8 positions, 8 connectors type of design. It explains to you the twisted pair there that has inside, which is actually twisted to avoid any sort of electromagnetic interference. Then we have the coaxial cabling, which is also used in the internet. Some service providers actually use coaxial cable, which altogether actually creates a broadband, so-called broadband connectivity, which is a high-speed connectivity, and fiber optics, of course, which is the newer technology, and that's what's being used now. There are different actually different types of fiber optics cabling. There's the single mode and multi-mode. The single mode uses a laser. Multi-mode actually uses an LED. And in multi-mode, the information actually, while it's traversing through the cabling, it jumps through the walls. And the single mode fiber cabling has a laser, which allows the information or the beam of light to go from one place to another in a straight line. It goes through further distances, up to even 40 kilometers for some technologies. So here we have also the physical media, which is wireless, Ethernet backbone, and the types of bandwidth that they're capable of. And here also the distances that we were talking about. Now, there's more information actually from the official Cisco websites. The other one that I wanted to show you is actually, let me see if we can go there right now. No, this one, we already saw this one. This one. All right, this also comes from the official Cisco website, and this is just the OSI model as well, which is kind of like a shortcut explaining all of them. Comes very handy when this type of can be used like a flashcard, actually, to remember shortly what corresponds to each of them. All right, and there are some mnemonics as well. All people seem to need data processing. That's a mnemonic that helps you remember. Application, all. People, presentation. SIM, session. To, transport. Need, network. Data, data link. Processing, physical. All people seem to need data processing, and that helps you remember all of the layers from the OSI. Then there's a way that actually packets are encapsulated and decapsulated too. And well, basically it's just how it goes backwards. That's the way it goes backwards. All right, thank you. Now I'll show you a little bit about those games that I told you about that helps us. They're very fun. They helps us do the conversion between decimal to binary.